Okay. So am I audible? Okay, so till now no one has joined effectively. So let me wait for a few minutes, then we can start. Okay, let me wait for a few more minutes if anybody joins. Okay, am I audible?
Yes.
Okay, so let me wait for one more minute, then we can start. If anybody else joins, then we can start. Do you have gone through the lectures uploaded in this week?
Yes.
Okay, so what do you feel? How was the lectures?
Good basic lectures.
Yes, because this course is basically the elementary or basic thermodynamics, whatever you want to say, but that is very fundamental even. This is the genesis of the thermodynamics. So this is very important to understand because later you will see in case of non-equilibrium thermodynamics or statistical thermodynamics, these all thermodynamics are basically embedded in this course, this base elementary thermodynamics. So that is the main building law. Because there is no formalism of thermodynamics. It's all about the laws, thermodynamic laws, which has been basically formulated by observing the nature, the universe. So this is basically the direct laws of nature, you can say. Till now you don't know why these laws are like this. Just like you have, I will discuss in today's class, but you know that entropy is always for universe, del S universe is always a positive quantity. Why this is? Anybody don't know basically, and this is the ultimate secret of nature, you can say, in universe.
Is this correct?
Yes, del S universe is always increasing, always. You don't know why this is, but this is happening always. And everything around you, any incident, anything happening that is guided by this fact, del S universe is greater than zero. That means
Is it related to thermodynamic arrow of time?
you can say like that because you can think like that our universe is now going to achieve some equilibrium. Okay, when it will achieve equilibrium, then the entropy del S will be zero. Basically, S will be constant, del S will be zero. That is a equilibrium state. In that case, there will be no arrow of time because if S is constant, then what will be signified by the time? Time when time concept of time appears, when something will be changed, right? That will be constant totally. So then you can say that time will be stopped like this thing. There's another theory that after reaching a certain value, entropy that will decrease, but nobody knows actually. There is a more formal way of saying the second law that entropy. Do you know about entropy production rate?
What?
Entropy production rate. This is
No.
okay. So it's the same thing that I will discuss. That entropy production rate, you can say in one term that entropy production rate, that sigma dot. It is sigma is entropy production and sigma dot is entropy production rate. So this entropy production rate will be positive. That's it. In one line, if you want to, if anybody want to know the thermodynamics, the one line is sigma dot is greater equals to zero. That is khatam.
We know very small thing about the universe. So how can we say this about the universe?
Okay, because this thing that universe is like that. how you can just you can think like if you have a beaker, let's say just a solution. So do you know this the logic that solution, if you take some part of the solution with spoon, the orientation of the molecules, the density, the every property, the sweetness, the sourness, everything will be same. If you consider the whole uh, solution, or you consider the one spoon of solution, this is called homogeneous mixture, right? These homogeneous, this
Yes.
these properties also be valid for universe. This is also a law. I don't know the exact name of this law, but you can feel that the laws of the universe will be similar in any earth or around sun. The laws are different, and around another in another galaxy the laws is something else. That would not be happened. So laws will be same. So here you can have the laws, that is entropy production rate is positive or entropy of the universe is getting increased. That will be followed in all over universe. Your part of the universe is not a special case. Okay. So
Okay.
why the laws of your part art will be different from the others? That should not be the case, na? So that is the logic. Okay. So let me share my screen first. Nobody else join, I think. Join. Okay. So it is visible.
Yes.
And that this obro bar is also visible, right?
Yes.
Okay, that probably, let me just check whether it is
Square box.
yes, just minimize. I want no, okay, no, a minute. I want to minimize. Ah, okay. I think it's now clearly visible.
No.
It's not visible.
The square is visible.
Square is visible.
Box. Square box.
This is not visible.
Screen is visible, but square box is visible also.
This square box.
Yes.
That is the format of my page. That I can change.
Okay.
You don't like this format? Then I can change.
No. 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 Okay.
Okay, okay. I just changed the format. Before it was just dotted like, so I just thought, let me try something different. Okay. So first, one question I thought in last class to be discussed, but I forgot. Not forget, there was lack of time also. That's why. Okay, so today I will start with that. That is called Kirchhoff equation. You know the Kirchhoff equation? So let me start. In class it was not discussed, and if you saw the upcoming lectures, the title of the upcoming lectures, you can see that Maxwell relations will be discussed in the next week, right? So
Yes.
that's why That's why I thought that after that classes in next week I will discuss the Maxwell relation and that thermodynamics squared. Okay. So for today's class it will be totally dedicated to the entropy, you can say, except this first question. And
Okay.
your Joule Thomson coefficient and that other part that I thought in after I think week 5 or week 6 there is just discussion of questions. So in that week I will discuss that, because in that week there will be no related topics to discuss. So in that week we can discuss easily the Joule Thomson coefficient. Okay, because
Okay.
that Joule Thomson coefficient or Joule coefficient, these two things are very subtle to discuss. Okay, very crucial things. So I thought I also I have to read something. I watch the videos, but from any books I have to read. Yeah, do you have read from Kessler?
Yes.
How was it?
Tough language.
Top language. Yes. Okay. I'll go home in next week. I have the book, but not here in my home. In the book was there, so I'll study from then. Then I will discuss it. Okay. Don't worry, that part we
Can
will
you please
discuss.
share your notes?
I will share, but for sharing that I have to go my home, right? Because the notes are that copy, in which copy I noted everything, that is in my home, because these are BSc level things now. So that copies I don't bring here.
Okay.
One thing, but they can give me PDF, but I thought that I will go home in 5 or 6 days. So that's why I thought after going home I will share you. Okay.
Okay.
So first derives the Kirchhoff equations. What are the Kirchhoff equations? Let me write it first. This is Kirchhoff equation 1. So can you guess what will be the Kirchhoff equation 2? Just analogously. What
Del
analog?
del H equal to del CPGT.
Exactly. So del H2 minus del H1. So always internal energy is related to volume and enthalpy is related to pressure. Means constant volume process and constant pressure process. So these two are called Kirchhoff
This is
equation.
for ideal gas.
What do you think? This is for ideal gas or what? What do you, can you guess?
Ideal gas.
चलो देखते हैं. Let us check.
For real, there is a temperature dependency also.
You are guessing from CVDT, right? So CVDT and then integration over CVDT from that
Yes.
perspective. Okay. Okay. So how you can prove that before? Let us pictorially understand. Del U is actually change of internal energy, and here we are measuring the change of internal energy. Can you guess understand that? Means this is a change in internal energy. This is another change in internal energy, and you are calculating the change between change in internal energy, right? So
Yes.
that means you have to consider two process. Okay, first process is let's say process 1. For that the corresponding internal energy change is delta U1, and the second process is U2. Second process and the corresponding change in internal energy is del U2, and we are going to measure that difference between the change in internal energy. Okay, so let me pictorially first understand. The first, let us start with process like this. Let's say this is state 1, any state, and we are changing it to any another state, that is state 2, and this is called process 1. Okay,
What process?
any process. This is general form, general equation. Any process, it may be isothermal, it may be adiabatic, anything. That we are not bothered about that. Okay, it's a general process. And let's say this goes to another. Someone joined, right? Yes. Okay. Okay. So let's say this is another process and this goes to state 3. So there are 3 states and this is process 2. For simplicity, we can write this is 1, 2, and this is 3. So these 3 are there. So now these any of these processes, let's say for this case, internal energy is U I, U2, and U3. These are 3 internal energy because internal energies are state function, you know this. Okay. And for this process, del U1 will be U2 minus U1 and del U2 U3 minus U1. Okay. And we are going to measure this difference between these two delta U, right? Is it clear?
Yes.
Okay. And not necessarily these two UI should be same. It can be another any process. Any process. For simplicity, I have shown like this. This process can be anything. There is no restriction. It's
Starting is
the
not same.
hmm?
Starting is not same.
No, no, no.
UI.
It can be different. It can be different. It can be different. No problem. Just it's
Okay.
very easy to derive. Just so formally, what we can write that del U is equal to U final minus U initial, right? In general, macroscopic definition of change in internal energy. Okay. So now,
Okay.
so now what you can write? This delta U, this will be function of what? Just you have to understand. U was function of
Volume and temperature.
volume and temperature. Correct? So now if this is volume and temperature, so now consider the if the process is constant volume process. Just revise these things. Nothing is there. Du was del U del Vt dV
T dV plus del U del T V
dt.
dt.
Correct? So now if it is a constant volume process, this part will be 0. So you can write it
Yes.
as CVDT. So it's not for ideal gas. Okay, it's a constant volume process. If it was an ideal gas, then this part will be 0, right? This would be 0.
Yes.
So here we are considering the constant volume process or isochoric process. So if it is an isochoric process, then what you can write du equals to CVDT. And that means you can write that U is a function of temperature
Temperature
only.
only.
Exactly, because there is no essence of dependency on volume. So what you can write? So now we have to measure delta U, delta T. If you are changing temperature, how much delta U will be changed? Just understand it. U is function of temperature. So now, if U is function of temperature, so obviously delta U will be function of temperature. This delta U also be function of temperature. In which temperature you are carrying this experiment or change, that will be temperature dependent. Now we want to measure how much change will be there in delta U if you change the temperature. Let's say the same experiment, this is the same experiment. If you consider this, if you done in T1 temperature and it was done in T2 temperature, same thing. That's why the second, this state and this state are different. Let's say this is T1 is, let's say 300 Kelvin and this is 200 Kelvin, like this. So you can guess that this delta U1 and delta U2 will be different. It's very trivial because state 2 and state 1 will not be the same. You can see this is
Yes.
CVDT. So it will not be same, obviously. So we have to measure that dependency of del U on that temperature. If you change the temperature, how much del U will be changed? That is our motto to calculate, and it's obviously a constant volume process. Is it clear?
Yes.
Okay. So what you can write from here? Delta U, you know. So delta U you have to find out. Delta U is actually, you can write it like
U final minus U initial.
du, integration over du,
Yes.
or you can write U final minus U initial, doesn't matter. So it's basically
Yes.
CVDT. So what you can write? So here, this part can be written like, is it okay?
Okay.
Okay, because delta U is eventually this will be used. Let for time being, because here it is already written. So it is U final minus U initial. That's why it will be this. So del U del T V. Del U del T V. What will be del U del T V? This is actually CV.
CVF.
CVF. So you can write it CVF minus CVI.
I.
So it's basically
Delta CV.
delta CV. Change in CV. It's clear? So it can be written that okay. If there is any doubt, you can ask. This is equals to delta CV.
Yes.
So and it's a constant volume process, obviously. How you can remember this? This is a constant volume process because here V is there, right? That's why.
Yes.
But it's for constant volume process. So now you can integrate it. T1 to T2. If you remember, this was T1, this is T2. So for when it was T1, the change in internal energy was delta U1. Just look at here. And here delta U2. It's correct.
Yes.
So limiting is correct. So delta U1, it is delta U2. So delta U2 minus delta U1 equals to integration T1 to T2 del CV. So this is our Kirchhoff equation. In general, what you can expect, if delta CV is temperature independent, if, then you can write delta CV delta T, T2 minus T1. If the delta CV is temperature independent, then in that is a special case.
When it is temperature independent.
What is the delta C, what is the CV?
Del U
This
del T
is
at constant V.
this property, right? So in general, this property. So if you remember in last class, that part we have already discussed. When it goes to higher
Which
temperature limit, the
yes.
CV is actually 3 by 2 kVt, right? 3 by 2 kV. So then it will be
Yes.
temperature independent. But if it is not a higher temperature limit, then obviously there will be a temperature dependence. Generally, it's
No, I
actually
am asking experimentally.
higher temperature. If you go, but this higher temperature has also some catch. That also depends on which type of gas you are assuming. Depends on that also. But in room temperature, you can say that delta CV will be the CV will be the temperature independent quantity.
That was theoretical approach, and for practical it is also same.
Hmm, obviously. When you goes to
Okay.
classical limit, it will be same. And you see, if CV is temperature independent, if CV is temperature independent, then CVF and CVI, these two, what is CVF and CVI? CVF and CVI both are same CV, same. If the gas is also same, why I said that these two state can be different. If let's say if we consider this picture, then you can directly understand that the CVI and the CVF will be the same if it is temperature
Yes.
independent. If CV is temperature independent, then it will be same and this will be zero. See, correct?
Yes.
So if you considering the CV is temperature independent, you have to remind these things. But when it will be different, if the initial state is also different, then you can say, okay, no, if initial state is different, then CBI and CVF cannot be same. So it's quite complicated. So in general, that's why we don't
Yes.
consider these things. In general, delta CVDT is the correct one. You can think if there is no temperature dependency on CV, then obviously del U2 and U1 will be the same. What does there will be no
Yes.
change, right? That is the case. That will be just related to dt. Okay, so similar way you can prove delta H. Should I do that, or you can
I
solve it?
can
It will be the same, but it will be
do
a
it.
constant pressure process, not a constant volume process.
Yes.
Just
Enthalpy will be only property of temperature.
yes. Just we can give a hint. My headphone is disconnected on me. Okay, so uh, let me connect it again. This perturbation will be always there. Hmm.
Perturbation and entropy are same or different?
Perturbation means not in perturbation means when you disturb a system from outside, that is called perturbation. Okay.
Okay, I was reading that part of quantum mechanics.
Hmm. Perturbation is very useful technique actually. But here this perturbation, this disconnection, that is very pathetic. Technical perturbation. So next now. Okay. So it's visible.
Yes.
So now if it is for enthalpy, then how we can do it? The same thing will be there. So I'm just writing, dH
Del H del T at constant P dt plus del H del P at constant T dP.
okay. So it is actually CPDT. And if it is a constant
Yes.
pressure process, then this part will be 0. So it's eventually CPDT. So now you have to just follow the same path, same definition.
Minus del H I by del TP.
Mm. So it eventually CPF minus CPI. So delta
Delta CP.
CP. So So this is our another Kirchhoff equation, same, but this is for constant pressure, and this was for constant volume. Okay, so now it's clear, I think. Now we can discuss the second law of thermodynamics, the entropy part. Okay, question number 2. What is the significance of entropy, right? That I already
Yes.
discussed to you. Just I want to discuss like this. Uh, let's say we are starting with a state A and we have to go at state B. So we are choosing a path that is a reversible path, or we can choose a path, a irreversible path. Okay, both path we can choose.
Yes.
So now, if you remember, uh, in our very first classes, we have discussed that delta Q, D cross Q, this was an inexact differential, right? That
Yes.
means it will depends on path, correct?
Yes.
So that from here, what you can say, delta Q reversible should not be equals to delta Q irreversible,
Yes.
because it is a path function, inexact differential, so it will be surely dependent on path. So
Yes.
if that is the case, but if you don't know entropy, then how you can think like entropy? I want to say, we have discussed that although delta d cross q is not a state function, but this is an inexact differential, but we can extract extract a exact differential from an inexact differential. Do you get it? Delta cross q is not an exact differential, it is an inexact
Yes.
differential, but
It by T
by
in between. Yeah.
modifying in a suitable way, you can define an exact differential. So by dividing by t, you can define it. So for simplicity, we are considering these both processes are isothermal. Okay. So if you consider both processes are isothermal, then it will be, we can define a quantity d cross q reversible by t and d cross q irreversible by t for two paths. Clear? So these two quantities, d cross q reversible by t or irreversible by t, whether it will be equal or different, it is very tricky.
Different.
It will be different, right? Why? Because delta cross q is irreversible, right?
Yes.
Okay. But now we can define entropy, that a quantity entropy defined by delta cross q reversible by t. It is not delta cross q by t. It is delta cross q reversible by t. So if you uh, go in a reversible path, if you choose a reversible path, then delta cross q by divided by t, that will define entropy. So it is ds. Is it clear? This is not ds. Okay.
Why?
By definition.
Okay.
We are defining like this, because if you remember, we argued that this entire thermodynamics is actually equilibrium thermodynamics, and that means we
Yes.
will only discuss about the reversible paths.
Reversible process.
That's why. Okay. So this is the definition of entropy. So how this definition appears in mind, this kind of arguments we can handle. Just look at our first law of thermodynamics, that was D cross Q, or there are two forms. Okay, let me write it. Is it correct? It's correct.
Yes.
So now if you put it, then it will be TdS minus PdV. These all laws, first law, and another form of the laws, everything was written down considering equilibrium thermodynamics, valid for reversible paths. So here we have not written reversible, these are not written, but you have to understand these are all reversible. Okay. These all equations are valid for reversible processes, not irreversible process. Okay. You have to keep in mind that we have not written anywhere it will not be written that it is reversible, but you have to understand that when it is not written, that means it's a reversible process. So
Aqueous
it is
bond.
yes. Okay, so that is del because q reversible by t, that is ds. So now if so is it visible?
Yes.
Oh, wastage of 5 minutes. Okay. Okay, so that is the this is the definition of ds, entropy change, right?
Please
Now
repeat.
okay, okay. So that in this is clear, right? That for two processors, the heat change del cross q will be different. Del cross q reversible and del
Yes.
cross irreversible will be the different. So now we are defining a state function entropy, which is an exact differential by this equation delta cross q reverse delta, no, d cross q reversible by t is ds. That is change in entropy. Okay. So now how you can calculate this change? So you can write it. So for time being, we can write this is reversible. Okay.
Yes.
So if you integrate it, so if it is a reversible process, then t will be constant, right?
Yes. For reversible, T will be constant.
Isothermal, not reversible, isothermal process.
Yes.
So you can write it. So this is also a definition of entropy. That is, the change in entropy is defined like this. U reversible. This is actually for macroscopic. So here we are discussing about this. We are discussing from state A to state B, state A to state B. So this is actually defining SB minus SA. Okay.
Yes.
Is it correct? That means for this path, the change in entropy, here the entropy was SA and here it is SB. So now if I ask, then what will be delta S irreversible? If you choose this path instead of this reversible path, this was reversible path. Instead of reversible path, if you choose the irreversible path, then what would be the del S irreversible?
dq irreversible by T
dq irreversible by T. Why?
because it's del S irreversible.
No, that's I'm saying. Nah, here is the catch. So definition of you should not, you have to always remind these things. Never mess up these things, okay? The entropy is defined by d cross q reversible by t always. Why? Because you know this entropy is now as is an exact differential. So it is a state function. So it will be the same. Okay.
Okay, okay.
So what you can write, delta S reversible equals to delta S irreversible, which essentially means SB minus SA, which means
DQ reversible by T.
D cross Q reversible by T. Okay, that's the case. It is from A to B. It is not equals to D cross Q irreversible by T. Never consider this is an delta S irreversible or these things. This is not delta S irreversible. Delta is irreversible and delta is reversible for same path is for different path from if the initial and final points are the same, then it will be the same also, same quantity. Okay, so this is the definition. Now the
Connection is lost.
connection is lost again.
Okay, now it's back.
Okay, okay, so you have to always remind these things. Okay, never mess up. Delta S reversible and irreversible are the same for both paths. The S is not a path dependent quantity, it's a state function.
Yes, state function.
That q that is a path function, so that will depend on path. So but we have relate the q for reversible path with the entropy. That is the definition of entropy. Okay,
Please
irreversible
repeat.
path
There
also
was a
will have
connection
the,
problem.
it's a connection problem, but it is not disconnected, it's connected. Okay,
Yes, but the words were not clear.
that what I can do. The internet issue in IITs, if the internet is like this, then what I can do.
What were you saying?
I'm saying that the q is a path function, so that will depend on path. So you have to keep in mind always, never uh, mistake these things. S is not a path function; it's a state function. So del S reversible and irreversible will be the same, but q will be the different, and the del S will be related with the reversible change of the heat. Okay, that is a thing.
Okay.
Now up to this is correct, but here is the main thing, that this is greater than this. Okay, this is called Clausius inequality. So Clausius inequality is delta cross q reversible is always greater than delta cross q irreversible.
Irreversible.
So this is the main thing. You can you can say this. This is the ultimate finding of thermodynamics. Ultimate thing. This sign,
This
this
is.
this is this sign will decide everything. This greater than sign. So Clausius, you can say the Clausius is the main, not only thermodynamics, in entire universe. That's the discussion we did at the beginning of the classes. Everything is driven by this. And there is no proof of this sign. This is just the observation scientists have in the experiments or in nature. From that, you can say this. How? That we'll see. So if this is, so from here you can write, okay, is it clear?
Yes.
Okay. So it is delta S ds, sorry, and it is d cross q reverses.
Is there any physical significance of the DQ irreversible by T?
Hmm. Yes, yes, that I will say. first
Okay.
understand this, then I will discuss that. Okay. So this is our Clausius inequality. This is very famous question. From here, lots of questions are asked. Clausius inequality.
This is the statement of Cauchy inequality.
Yes. Or you can write it like this also. This is a form. Another form is this, like this is also correct, where this is for irreversible process, this is for reversible process.
I was
Okay,
reading a book. There was a close integral of dq reversible by t.
that is also a form. You can make it from here. If it is a closed integral, let's say ds, you have seen that or you have seen that because q reversible by t is 0. Which one?
The last one, close integral dq reversible by t equal to 0.
The same thing, na? Same thing. Just look at it. This lesson you have to understand nothing. If it is a closed integral, let's consider this is this path, this path. Then you can say closed integral of d cross q reversible by t, that is eventually ds. So you can say it. So it will be 0 anyway
Yes.
because it's a straight function. But this is it, where is the inequality? This is not inequality. You can say if it is an irreversible process, if it is an how you can write it? Okay, let me do it. So let's say the same, just I have shown different way, nothing else. Let's say this path, you go in reversible path and you came back in irreversible path, then delta s will be first step, delta s forward, that is delta s reversible, plus delta s backward, that is delta s irreversible. Correct?
Yes.
So it is sb minus sa, and it's also the same. You have to remind that reversible and irreversible change will be the same. So it is 0.
Yes.
And delta s irreversible is actually delta cross q by delta cross q d cross q reversible by t from a to b, and this is not. You can write it delta cross q reversible, you can write it like that. It is not that case, right?
Yes.
So what you can write it, you can write it actually, it is actually delta s irreversible, and reversible irreversible is same, so it is 0. But if you include the Clausius inequality, that is this delta cross q e is greater than that is less than ds. So if you put it, then you will have, that is something b2a, that is irreversible by t, so that will be less than 0, something like that. So if you rearrange it, that is, yes, b2a, it's correct. So if you rearrange it, you will have b cross q reversible by t, a to b is greater than the same thing, right?
Yes.
So this is actually Clausius inequality. Ultimately, the statement is the same. The way of representation may be different, but it's the same thing. Okay.
For reversible it's equal and for irreversible it's greater than.
Just summarizing it, ds, this is the general form. If it is reversible, then it will be equal because q reversible by t. That is the definition of entropy.
Yes.
And if it is irreversible, then it is greater than d cross q irreversible by t. And if you remind, these two things are same. So this is the Clausius inequality. Okay, is it clear?
Yes.
Okay.
Yes.
So now take it. So that's why we don't write any ds reversible or irreversible, because ds is same for both cases. So now consider this quantity. Now you are saying the significance of this part, right? So
Mm.
it is less than this, right? So what we can write, just understand it. We can write it.
Yes.
Okay. Or
It is reversible or irreversible?
sorry, correct, sigma. Oh, we can choose any sign. This is correct.
Yes.
For now it is evident, it's very much clear that sigma is 0 for reversible process. In
Yes.
general, you can write it. Sigma is 0 for reversible process, and sigma is greater than 0 for
Irreversible process.
irreversible process always. So this is also Clausius inequality. The same thing. This sign is carrying forward, right? Sigma is greater or equal to 0. The same thing. So how you can understand that if it is an irreversible process, if it is reversible, then it's okay. Then it will be 0. Correct? You know. But if it is an irreversible process, then it is actually greater than 0. And these two things are same.
Yes.
Okay. So what you can say that this sigma, if you equate these two things, then you can say the sigma irreversible is nothing but 1 by t delta cross q reversible minus delta cross q irreversible. Right?
Yes.
Okay. Now coming to the physical significance. You are considering a process that is A to B in both cases. Both cases it is A to B. So when you consider the reversible path, that d cross q, the change in heat, the change in heat divided by T, that is actually the reason behind increment of entropy, right?
Yes.
What does it mean? Let's say A and B. Now we are defining A and B. A was this, like this, and B is isothermally this expansion of a gas. So in reversible, if you remember, we just slightly decrease the pressure. That's why the piston is getting up very slowly, and that is reversible process, right? And
Yes.
in this reversible process, we are giving actually the heat. Heat we are giving, and that's why the piston is going up upwards. So that d cross q you are giving, that d cross q reversible by T, that is actually the this. Okay, is it clear?
Yes.
Okay, so if it is the case, then uh, now if you consider the irreversible path, irreversible, you know, just you push the piston directly, and that's why the expansion of gas will be very rapid. Now you see, for that you need a less amount of heat, and you
Yes.
if you remember the plot PV diagram, then you can understand this. It will why it is less. This was the PV diagram. If it is an like that, so the area under the curve, this is the amount of work done for a reversible process. Correct? Do you,
Yes.
do you remember?
Yes.
So the work done and the heat will be the same because it's a isothermal process.
Yes.
So but it was P1 V1, let's say P2 V2. But when you consider just this is a irreversible process, then it will be just P2 into V2 minus V1, right?
Yes.
So this is the amount of work done or heat you can say for irreversible path. So clearly it is less than this.
Yes.
But ultimately the del S should be the same.
Yes.
So that rest amount of entropy is actually guided by this part. Like this, for reversible path, let's say this is 100. So this is 100. So it will be 100, it will not be changed. But now this is 90, correct? So the rest of the amount will be given by this sigma. Okay?
Okay.
1 minute, it's okay, but let me connect it. Very bad network. I must say. Okay. So now what is the physical significance? So this is called entropy production because this entropy is automatically produced in the system. Okay, is it clear?
By how it is produced?
Nobody knows. That's I'm saying now. When it is an irreversible process, to make up that rest of the amount, the universe actually you can say this amount of entropy is generated by its own. That is called the entropy production. So
Because
when the
in both case entropy has to be same.
in other way around you can say when it is a reversible process, the entropy production is zero. But when you change it in a irreversible manner, that means it's a spontaneous process, right? You know, the
Yes.
irreversible process is a non-equilibrium spontaneous process. So for that case, entropy production will be non-zero, and that will be the same. Ultimately, del is reversible and irreversible. So from here, you can say when this entropy production sigma is positive, entropy production is positive, it is actually the irreversible process.
Irreversible process.
Yes. Or in general, it is actually considered sigma dot. Sigma dot is del sigma del. The rate, production rate. This is
Rate
entropy
of change
production.
of sigma.
Yes. So sigma is entropy production. So it is entropy production rate. So that is the everything. So it should be greater than zero. Not sigma dot is greater than zero. That is a more superior definition. That should be the case.
Why?
That we can leave. That is discussion of non-equilibrium. But here you can see if sigma is greater than zero, sigma is increasing, right? Increasing with time. It is actually increasing with time. When you consider a if you let's say if it is a negative time direction, then sigma may be negative. So for argue that fact, we have to consider the sigma dot.
Okay.
So you know this figure, you know this is that entropy, and this is time. So this is like this. So that's why time appears here. The entropy is increasing, 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 and after that it will be constant. Or you can plot it like sigma, sigma increasing, 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 and after that it will be constant. Just see why it is important. Sigma dot is why sigma dot is important. Mm, because when it is a when sigma is constant, sigma dot is zero. Clear?
Zero.
Okay. So forget it. There will be two terms, steady state equilibrium. I'm not getting into that. But just if you this is sigma entire production rate, sigma dot, it will govern everything. Okay. That is actually the Clausius inequality in just another way of representation. Okay. Now let us discuss some numerical question. It's lots of. Okay. 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 This formula you know. First prove it. Then I will discuss numerical question. For reversible change of ideal gas, proof. Reversible ideal.
T2 by T1 plus NRln V2 by V1.
That you know. That you know. But these two. These three equation looks similar, right? Three equations are similar. So let us start with the
Yes.
first one. That delta S. So ds is
Integration dq reversible by T.
okay. Good. Then what law we have to use? First law. What is the first law? Because Q minus
Equals to minus dw. Du is 0.
why du is zero.
Isothermal.
No, here where is isothermal?
Sorry. No. CVDT.
So it is CVDT plus PdV. So we can write it CVDT by T plus PdV by T.
Yes.
Considering Cv is constant, independent of temperature, not constant. So it is again
Yes.
T2 by T1,
T1.
and it will be P is,
nRT by V.
so P by T is Nr by V. So it is NRln V2 by V1.
V2 by V1.
So first one is proved. Straightforward. Now you know Cp minus Cv equals to,
NR.
for ideal gas,
Yes.
correct?
Yes.
So put it. Okay. Is it correct?
Yes.
Think so. Now Pv equals to
nRT.
nRT. Now here we are changing. Just see, this S is changing. That means the state that is actually changing from V1 T1 N to V2 T2
V2
NR.
T2.
Okay, so these two things are changing, but here here pressure is also not constant. Here pressure is also changing. In that case, pressure was constant. Pressure was constant, so you can use this formula when pressure is constant. Just we have changed this pressure. Pressure is independent. Okay, just forget it like this. Let's say pressure is also changing. Just N1, N2 is constant. Okay,
Okay.
so here you can write it. So P1 is actually NR T1 by V1. And P2 is NR T2 by V2. So T1 by T2 by V2 is actually NR by P2, and it is NR by P1,
Yes.
or it's other way around. I've done the correct thing. Just check the signs.
Yes. It will be inverse because it's minus log.
CP minus NR, I think. Well, let's say just do it like this. Okay. P2 by P1, right?
How it is okay?
It was our definition. Up to it's correct. Just put
Yes.
CB equal to CP minus NR.
Yes.
Now just we can reverse this, and it will be plus.
Yes.
Then it will
So
be
why the
plus,
sign is negative?
not negative, plus.
Okay.
So NR this, and T1 by V1 is T1 by V1 is there. So T1 by V1 is P1, and it is
P1 by NR.
plus. Correct?
Yes.
It's correct. So just reverse it. It is minus. I was I Now it's clear.
Yes.
So this is our second form. Now the third form. So in third form there is no NR. So just use, instead of NR, what we will use? CP minus CP.
CB.
Okay. T2 by P2. What is T2 by P2? That is V2 by NR, right?
Yes.
Or P by P is actually V by NR. So it is NR V2, and this is NR by
V1.
V1. No, again it
CP
should
ln
be
V1 by V2.
V2 by V1. Just check. NR is CP minus CB. That's correct. It's correct. Oh. T2 by P2,
It
right?
is inverse. Yes, it is inverse.
So T2 by P2 means V2 by NR. and it is V1.
Yes.
I just remind that always 2 will be in numerator.
For every expression, 2 is in numerator.
Just see, for first
Yes.
expression, every expression, but this is minus. In that
Yes.
way, you have to remind this formula only. Then other two you can derive. This formula is
Yes.
not that much used. These two are used oftenly. Okay, just we can do an example regarding this formula. From a state A at 10 atm and 300 Kelvin, 600 Kelvin. If the value of CPM okay,
Yes.
right, then I will.
Okay.
Okay, so you have to calculate the del S, that is SB minus SA. Okay, so at state A is 10 atm pressure and 300 Kelvin temperature. State B is 100 atm pressure, 600 Kelvin of temperature. Okay, so now you have to calculate the, so which formula we should use?
Cp ln T2 by T1 minus NL ln P2 by P1.
It's because you have to see here what values are given, that
Cp
pressure, change in pressure and change in temperature.
temperature.
So that was in case of this formula. No, here is temperature and volume. Temperature and pressure. Temperature and pressure is, oh, I have written wrong. This is P, right?
Yes, it is P2 by P1.
P2 by P1. So this formula will be used. So now del S is Cp ln P2 by P1 minus NR ln P2 by P1. So N is 10, CPM is given. CPM is for 1 mole, but here that is actually 10 mole. So it is actually 69.95. ln 2 minus 10R ln 10. Is it clear?
Yes.
Now just do it. So what is the value of ln 2 when you calculate?
0.693.
Okay, okay. Radioactivity, right? Rate constant.
Yes.
Okay. So, but multiplication we need, yeah? So better use calculator.
48.5.
48.848, 48.485 minus 10 ln 10 R. What value of R we should consider?
1.987
Why? Because it is in calorie per mole.
calorie.
So it is 1. So it is 10 into 1.987, right?
Yes.
So it is 19.87 into ln 10. So
45.75.
so if you, what will be the answer? Minus 2.72. Not minus, plus 2.72. So
Plus
this is
2.72.
so this is the change in entropy. Okay, this is some numerical question, and now we have to discuss other one. I have lots of questions, but let's see how much we can discuss. One theoretical question is there, but that I will discuss at last. Before that, I will discuss few analytical numerical question. Question number 5. Assuming that there is no chemical reaction. If you notice, we are dealing everything in closed system, canonical ensemble, because number of particle
Yes.
is conserved everywhere, but the energy is being exchanged. Everything is happening under canonical ensemble closed system. So, but when the number of particle will be uh, coming into the action, then everything will be very different and difficult. So that's why there is no chemical reaction till now. The change in entropy when 2 moles of N2, 3 moles of H2 and 2 moles of ammonia are mixed at constant temperature. Okay, that is del S mix. What was the formula for del S mix?
Minus NR summation xi ln xi.
This is the formula. So just we have to calculate the X. First, what is NH2? N2, sorry, N2
3,
is
2.
and ammonia is 2. So XN2 is
2/7. 3/7 and 2/7.
just put it. So it is actually minus 7R. Then 2 by 7 ln 2 by 7 plus 3 by 7 ln 3 by 7 plus 2 by 7 ln 2 by 7. Okay, is it clear?
Yes.
Ln A plus ln B, it is ln AB, right?
Yes.
So we can write it
2 to the power 4 into 3 to the power 3. 27.
what will be the answer now? I don't know.
6.06 total ln.
You checked it?
Yes. 6.0684.
Let me check also. ln 432.
And total answer is 50.452.
What was your value? ln value,
Total answer
the ln part.
6.0684.
Now you see, this is a constant, right? This is a just number constant. This is
Yes.
will decide the unit. So it's up to you in what unit you want to consider. So if it is joule, then it will be
8.314.
314. So it is 50 point minus 50.452
452.
joule per Kelvin inverse, then per mole, right? This should be the unit. If I'm not wrong, I may be wrong. No, only Kelvin inverse, no mole inverse. Okay.
Okay.
So, okay, that should be because it is d cross q by T, entropy.
Yes.
So, joule per Kelvin. Okay. So, this is question number 5. So, now question number 6. This question is easy for anybody. I should not discuss. Okay, another same type of question. How do we discuss? चलो कर ही लेते हैं same type. The entropy of mixing of 10 moles of helium, 10 moles of oxygen, and 10 moles of, oh, just these two. No, and at constant temperature and pressure assuming both are ideal gas. It's very easy, right?
Yes.
So same formula, but this question will solve using a different formula. We can write it.
Yes.
So we will use this formula. This is more easier. So Na helium is also 2 mole. N Oxygen is also 2 mole.
10 mole.
10 mole, right? Not 2 mole. Oh, 10 mole, yes. What? 10, 10. So what will be the X helium? Half.
1 by 2, 1 by 2.
So it will be just minus R 10 ln 2 plus 10 ln 2, and this minus will goes away.
Yes.
1 minute. In last case we did some mistake. Where is the mistake? Because this
Is
minus
plus.
symbol will not be there.
Yes.
तो कहाँ से आया? Where was the mistake?
The adding 2 by 7, ln 2 by 7, 3 by 7, ln 3 by
Oh,
7.
okay. Here is hmm, so minus 3 ln 7 is there, right? So this should not be the answer. We have done
Yes.
wrong. The 7 will cancel out. This 7 will cancel out, but that will be there. So it is 2 ln 2 by 7. So it is 4 ln 2 by 7 plus 3 ln 3 by 7. Okay. I think now it's correct.
Yes.
Okay. So what we can write? 4 ln 2 plus 3 ln 3 minus 4 ln 7 minus 3 ln 7.
Yes.
So this part, what was the answer? This you can calculate.
Minus 7.553.
Total.
No, this ln part.
This part, right?
Yes.
7 minus 7 point.
553.
Or minus 7.553. And now multiply it with this R. It will gives you.
Minus 62.795.
Now it's correct. 63 is the answer given. Probably there is some error. Okay. So this will be
Okay.
the answer. So it should be always positive, because the
Yes. Deless mixing always.
for spontaneous process that we have discussed,
Yes.
it should be positive. Then only it will be a spontaneous process. Otherwise, you have to mix it. Okay, so it is 10 ln 2, 10 ln 2, right? So it is eventually
Yes.
20 ln 2. Just do it.
115.232 total. What is the answer?
115.3. So it's correct. Okay, now going to question number 7. The change in entropy when 1 mole of an ideal gas is compressed to 1/4 of its initial volume and simultaneously heated to twice its initial temperature. So which formula should we use? We have to calculate change in entropy.
Cp ln T2 by T1 plus nr ln V2 by V1.
Why? No. Temperature is changing and volume is changing.
Yes.
So CV.
So sorry, Cv ln T2 by T1
Yeah.
plus nr ln V2 by V1. Sorry.
Yes. So CV is given. No. Okay. It's not
No.
that numerical question. It's just they want to know the expression. So it is CV ln T2 by T1. What is T2 and T1? Mm,
T2 equals to 2 T1.
it's 2 and it is 1 by 4. Okay. Is it okay?
0.693 Cv plus 1.38 nr.
But that is not needed.
Okay.
That is the answer. Okay. Or you can write it as
Yes.
that is also correct. Or what else you can write it? CP is it CP minus CP. Huh. That is the better answer, I think. Is it correct? No.
Yes. Why? Oh, okay. Sorry.
So it should be not negative. How it can be negative? There is something wrong.
nr is Cp minus Cv.
NR is CP minus CP, so it will be plus, right?
Yes.
Yes. So it is 2 CP minus P. So there are always checkpoint. You can check that delta S is can't never be negative. So it is the answer.
Yes.
So, or you can write it CV 2 minus gamma L2. Okay.
Yes.
Just to have taken the CV out, so it will be this. And you know that the value of gamma, for any gas, which gas you are talking
Yes.
about, you know the value of gamma. Just put it. You know the CV, and from here you can always derive. Or in general, you can try it. Okay. So that's the final answer. In question option, it was the correct option, right? So you have to figure it out.
Okay.
Because it is very straightforward. Up to this is correct, but you have to formulate the answer according to your option, available option. That is also very important for your competitive exams, because there you know the answer, but you have to match with the correct option. For that, you have to make the in between steps. You have to manipulate your form of the answer like this, so that you can have the right form
What is
option
the
B.
tricks for that?
You have to just look at. I have seen there is a gamma, so that's why I am looking about CP and CB both the term.
Yes.
That's why I have used here. Or other way, you have to take each and every option and you have to expand. That you can do. Because you know
Okay.
gamma, then you can take it 2 minus gamma, then just the reverse way. And you have to do it for other options as well. If you are lucky enough, then you will get the right answer for the first time, first try. Otherwise, you have to try. Okay, so now, okay, different type of question. Let me find out. This question is very good, but this will be after Maxwell lesson. Let me check. Another question. Okay, regarding Carnot cycle. Carnot cycle is discussed in class, right? So is there any doubt in Carnot
Yes.
cycle?
No.
Okay. But the one thing now to define, that is the coefficient of performance.
For refrigerator.
Hmm. That should I discuss, or I should discuss the refrigerator? Okay, in next class I will discuss refrigerator, then I will discuss it. Because otherwise, before that, just do it. Plot of Carnot cycle with respect to first enthalpy versus entropy, volume versus temperature, temperature versus volume. Okay, is it correct? चलो देखते हैं. So what is the Carnot cycle? I
It
have
is
not.
4-step cycle.
Yes, it's irreversible. Sorry, reversible cycle.
Reversible. Yes. Cyclic process.
Yes, which has 4 strokes. Let us start with this. It is P1, B1.
Isothermal expansion.
First is this isothermal expansion to P2, B2. This is isothermal expansion, means it's occurring at TH, higher temperature, and heat is coming. QH amount of heat from hot bath. This is isothermal expansion.
Then
Okay.
adiabatic expansion.
If QH amount of heat is coming, that means WH amount of work is there. So let it is
Yes.
P1 and W1. This is adiabatic expansion. So it is adiabatic expansion. Here, temperature will not be the same. Temperature is changing.
Yes. But no
Here,
heat is.
here temperature was, let's say TH is the temperature in both cases. Here it is T lower or T cold, hot cold. And here you see it is adiabatic, so no heat will be there, only Q.
Yes.
So it will be Q2 amount of work by the system. It is again P4, V4, PC, and this is compression at isothermal compression
Compression.
at temperature PC. So compression means work done on the system and it will coming out.
Work is positive.
Wait. Okay, this is adiabatic compression
Compression.
and temperature is so here, work done on the system. So this is our total Carnot cycle. Okay, so you know this cycle. Just we have to formulate this cycle like in according to this. So first one is enthalpy versus entropy. We have to plot enthalpy versus entropy. So A, B, C, D. So okay, let's say this is our state A, which is P1, V1, and pH. So isothermal process. So in isothermal process, you know, for isothermal process, du is 0, right?
Yes.
So dH will be, you know, dH is du
Minus
plus,
PdV. Sorry, plus PdV.
okay. No,
Yes.
pressure is also changing. Pressure is also changing, no?
Okay.
So VDP, PdV plus VDP here. Or you can
Delta
write
of
it.
P.
Oh, okay. Or what you can write it here. So as it is a isothermal process, temperature is fixed. Okay, so du is eventually TdS minus TdP plus V. So it is TdS minus
VDP.
VdP. Okay, and you know ds is eventually d cross q by t.
Yes.
So and q is coming into the system, so entropy will be positive. Clear? So
Yes.
for A to B, for this path, entropy will be positive. The entropy change will be positive. So anywhere here. Now enthalpy. So if ds, so enthalpy. What about dH for A to B?
Yes.
No, no.
Blue screen is visible.
Ah, now it will come. Hmm. Okay. So ds is positive. Okay, but what is a dH? That means I want to have HB minus HA. What will be that?
Volume is increasing, so it is increasing.
No, it's actually zero.
It is zero.
Hmm. For constant pressure process, for ideal gas, you have to remind this Carnot cycle is for ideal gas.
Yes, yes, it is zero.
Then it will be zero. No, PdB and VdP will be same for ideal gas. Here from here it is PdV minus VdP. It's correct. Now you have to integrate it now. So del H will be this. So what is P? It is NR. It will be NR ln V2 by V1,
V2 by V1.
and it will be NR ln P2 by P1.
V2 by V1.
So it will be same. So it is NR ln P1, P2 V2 by P1 V1, and both are same. So it will be 0. Okay. So that means S is positive, but H is 0. So it will be like this. Is it clear?
Yes.
Okay. So A and B we have now. Next is B to C. It is adiabatic. Adiabatic means D cross Q is 0. So
Isoentropic.
isoentropy. Correct. So it will be, okay. Entropy will be same, but what about H? ds is 0. So dH is minus VdP. And pressure is increasing. So H will be decreasing.
Yes.
Clear? So it will be C should be here. So this path was our isothermal expression. This is our adiabatic expansion. It is a TH. Here is TH to TC changing. Now again it will be now same. It will be adiabatic isothermal compression at TC, and it will be adiabatic compression at TC to TH. Is it clear? So the
Yes.
curve will look like this. So this is in H and S. Next was our, this is not V, this is U. U and T. This type of question is very common in NET, GATE, JAM. So U and T. So let's say this is our state A. Now adiabatic expansion. So in case of adiabatic expansion, isothermal
Isothermal.
expansion, temperature will be fixed and the
Internal change will be zero.
0. So it will, A will be here. So A will be here. And this is anywhere, let's say from in between I'm writing. If it is A, it will be also B. A, B at the same point.
Yes. Maybe on same point.
Now going to B to C, this is adiabatic expansion. So if it is adiabatic expansion, so temperature is decreasing. So if
Yes.
temperature is, so temperature will decrease. Temperature will decrease means internal energy will also be decreased.
Yes.
Anywhere around here, C, and you can understand C and D will be also the same because it's also isothermal compression. So it will be our clear.
Yes.
And another one is there, that is P versus V. So it's very easy. First one is isothermal. So
Yes.
it is equal to
Temperature straight line.
straight line and volume is increasing. Then temperature is increasing, volume is also increasing like this.
Yes.
Then volume is
Temperature is constant.
temperature
Volume
is
is
constant
decreasing.
increasing and then this. Just this is very easy. So this is our uh, in PV diagram. These are all Carnot cycle.
What are the important questions in this format?
No, they ask what will be the graph look like, what will be the strokes look like in PV diagram or PV diagram. Generally, we discussed in PV diagram, right? But these
Yes.
diagrams are also important. You have to
Yes, I am asking the different types. That means T versus B and like another if
T versus P may be there, or
T
another
versus
state
P.
T versus P, another state function, A versus S, H versus A, G versus S, something, anything they can ask.
How to do it?
Just following the same method. Just first you have to consider isothermal expansion. You know, for isothermal expansion, all state function change will be zero. It is enthalpy, entropy, not entropy, sorry, enthalpy, internal energy, or it can be now Gibbs free energy. Gibbs free energy is actually, what is the definition? G equal to H minus Ts, so it will be minus Ts like this.
Yes.
You have to do it. Just you have to have the understand the relative position. That's it. Whether it is in straight line or curved line. And then you have option and you can eliminate. You can choose the right option. Okay. There are lots of questions. Today, let me discuss this one. Then in next class, I will discuss this Carnot efficiency and Maxwell relations will be there. So now this question, what percentage of EL of EH, this is higher and lower, just similar to hot and cold, for a 10% efficiency. What will be the answer?
Please wait.
Okay, this is very easy. I will wait. Close electron is there. Okay.
90%.
90. Check. Let me check. 90%. So just let me do it. It's very easy. So you know we want to have eta. Eta is actually pH minus L by TH.
By pH.
We want 10% efficiency. 10% efficiency, eta is 0.1. So 1 minus L by TH is 0.1. That means L is 0.9 into pH. That means 90%. Clear? Nothing is there. Very straightforward.
Yes.
Okay. So this will be last question probably. Let me, yes. Question number 10. What is the free energy change accompanying the compression of 1 mole of a gas at 57 degrees centigrade from 25 to 200 atm. Okay, no, this question you can't do. Sorry. Here one concept is required. Sorry. This question I will discuss later after discussing fugacity. Some concept of fugacity will be required here. So this question I can't do.
Okay.
Okay, let me do one more question because we have time. This will be large and it will take time. Okay, let me see if these questions are correct or not. Hmm. This we can do. Okay. 1 mole of an ideal gas, not ideal, it's also monoatomic ideal gas, is allowed to expand isothermally at 300 Kelvin from 1 atm to 0.1 atm. Okay. Pressure. Okay. So del G for reversible process and irreversible process. Okay, so first, so we have to calculate del G, which is GB minus GA. What is A? A is,
Helmholtz free energy.
no, I'm saying the state. Let's say state A to state B like this. This is the expansion, isothermal expansion. So T is constant, right? That's why it's 300 Kelvin. And it is 1 atm
Yes.
to 0.1 atm. So what is the formula of del G? G is
H minus Ts.
Ts. Okay.
Yes.
What is H? du plus pdv
PdV.
plus vdp,
VdP.
and du is pds minus pdv
Minus PdV.
plus pdv, and minus pdv will cancel out, and it
Yes.
will cancel out. So it will be vdp minus sdt.
Yes.
And isothermal means it is
T
minus
is
P.
0. DT is 0.
So it is vdp only. So you have to,
Yes.
so it will be integration of vdp from p1 to p2. So, and it is ideal
Yes.
gas. So what we can write it? 1 mole. So it will be RT by pdp. So it will be
Yes.
RT ln p2 by p1. Okay, and we have to use what, that is liter atm, right?
Yes.
Because it is okay, that's not necessary. We
No,
can,
because it's cancelling.
it's cancelling. So ln p2 by p1, it will be minus 8.314 into 300, and it is ln 10.
2.303 ln 10.
So it will be, you can calculate it. 8.314 into 300 into ln 10. It will be
Minus 5743.1077.
61.077.
5743.
I am getting 61. You are doing in calculator?
Yes.
Okay, let it be whatever. It is up calculator. So 5.7 kilojoule. Okay. This is for
Okay.
reversible. And for irreversible, you should try. What will be the answer?
Del G state function.
Exactly, so it will be same. So it will be
Yes.
same. This type of tricks they can ask. It is
Okay.
state function, so it will be the same. Okay. So, okay. For today's, it's enough. In next class, I will discuss some question from Carnot cycle. Carnot cycle. After that, I will discuss that Maxwell relations probably and the other questions. Okay.
And the remaining questions.
Which remaining questions?
Today's remaining questions.
No, that I will always discuss. No question will be. I have made the question. I have select some question from previous year question paper and I have made some questions, so I have to discuss it. Don't
Okay.
worry, that I will discuss. Okay. So do you have any question regarding today's class? Otherwise we can stop.
No.
Okay. So let me stop sharing first. Okay. Okay, so we'll meet again next Sunday at 4 p.m.
Okay. Thank you.
Okay. So we can end our meeting soon now. Okay.